Well, I am in Aura, Sweden at the moment for Winter Wind, which is the icing winter blade conference held in Sweden every year. And Joel, it's just like I imagine Sweden. It is beautiful, but it is ultra cold and very snowy.
The people are nice, though. The people are nice.
Oh, yeah. It's a lovely people actually enjoying the food and the company here. And it's a pretty well-attended conference. It starts off tomorrow. They had a little bit of adventures this afternoon, but the conference itself starts tomorrow. Really looking forward to learning a lot about wind turbine anti-icing, some of the issues they're having with AEP and icing, and trying to keep these wind turbines running in these really harsh winter conditions. And I'm used to cold. It's cold here. This is beyond cold. So this week we have a number of great topics. China has a compressed air energy storage system, 100 megawatt system that is pretty unique, and Rosemary goes through some of the details there. Then we look at the EU and the United States are doing battle on how much money they can pour into renewable energy and how that's going to end up as both the United States and the European Union try to keep their technologies in their countries. And then GE is demonstrating a scalable direct air capture system for CO2 removal, and we look into that and where that technology may be used.
And we're jumping back from directly into the wind world with Onyx Insights, a company that we know for some CMS monitoring, but also starting to partner up with Nearthlab out of South Korea. With their drone technology to help some of their clients with blades. Alan and I have been talking in the background about some Nordex towers made out of concrete that are going to get actually blown up and have a demolition due to some defects in the towers themselves. So a little bit of trouble there with the concrete towers. And then jumping down in the Gulf of Mexico, talking about a Cat 5 hurricane-proof wind turbines that Gulf Wind and Shell are teaming up on to be able to deploy in the Gulf. And then we jump into our wind farm of the week. So we're over in California this week talking about Lompoc at the Strauss Wind Energy Project.
I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with my good friend from Wind Power Lab, Joel Saxum, and Australian renewable expert, Rosemary Barnes. And this is the Uptime Wind Energy Podcast. Right over in China, commercial operations have started on the world's first 100 megawatt compressed air energy storage plant. And this is pretty unique. That plant can generate 132 million kilowatt hours of electricity annually. And that's enough to power about 40 to 60,000 homes during peak electricity consumption. And the way that compressed air energy storage works is that when they use electricity when it's off hours and they have an excess of electricity to run a compressor, which then compresses the air into these tanks. These tanks are stored underground, and then when they need the electricity, they call on these compressed tanks to spin a little generator, and you're powering the grid again. But something on this scale, 100 megawatts, is a pretty good size system. We haven't seen anything like this in Europe or in the United States, I don't think. I know there's talk about it, but Rosemary, is this the largest system that you know of in a compressed air energy storage network?
Yeah, I'm pretty sure that it's the largest by a fair way. Compressed air energy storage, it's one of those ones that people have been talking about a lot for at least a couple of years. It's not a new technology. You know, we've been able to compress air and decompress it for a long time. There's no, special high tech new devices needed to make this work. It's more a matter of someone just saying, yeah, we can recognize the potential on paper, and now we want to take it from being an on paper, possibility to actually make one and use one. And it's not really surprising that China would be the first ones to make this happen because, one, they haven't got to worry so much about the business case. making 100% sense now because of the way that they run their economy. And two, they're kind of the first on nearly everything. I cover heaps of different energy storage and energy generation technologies on my channel. And very often it's China that's moving the fastest. I've got one coming out next week on concentrated solar power. And even though China doesn't have close to the best resources for that in the world, they're moving probably the fastest out of everyone. So yeah, they're kind of looking a bit ahead into what technologies they're going to need, and they're building them now. Whereas, in economies like Australia's or the US or even in Europe, it's more about, well, we know that we will need that, but we don't actually need it until more coal plants start closing down. So it means that, if you built one now and, as a private company and tried to make money, you wouldn't, because we don't actually need the storage that much.
And this is different than lithium batteries in what way? Is this lithium's much more energy efficient than compressed air? Is that the difference?
It's more suitable for long duration storage. And I've read 3, 4, 5 articles on this project trying to find out how much energy storage there actually is, because, it's 100 megawatts. That's the power, the instantaneous, amount that it provides. But that's what you would use a lithium ion battery if it was for just a short duration. The only reason you would go to compressed air, is if you want a long duration, and then you need to know how much energy is in it, how many megawatt hours. And I can't find that anywhere. This annual figure, it doesn't really help you because it totally depends how much you use it. If you're doing 1 cycle per day, then that would be one amount. And if you did 2 cycles per day, then you would double it, but it would be the exact same battery. It would just be, using it differently. So it's my pet peeve and everyone's pet peeve, I think, when they announce an energy storage project and don't tell you how much energy it stores. It's like, what do you, so any journalists or people writing press releases, please take note and correct that in the future, because it's a pain.
I think one of the advantages here over like a lithium storage is, of course, you're not using rare earth minerals, right? I mean, it's steel and some technology that we already know, right? So it's some compressor stations and a bunch of steel and some iron here and some electronics here. It's nothing too crazy, and it's not really resource depleting to build storage facilities of this size for compressed air.
Yeah, that's true. And it's a lot less efficient than a lot of other energy storage technologies. So, you don't get all of the energy back that you put into it, but because it's in theory so cheap, then you still see a big benefit from having it in the system. And so it is cool to see. There's a whole list of energy storage technologies that could work well on paper, should be cheaper than lithium ion batteries for longer storage durations. It's good to see them coming off the paper and into a real design. And, we won't probably find out the economics of this project since it's in China, but obviously the more projects that get made, it's going to, if it works well, it's going to spread throughout the world. And so it's kind of the next phase of the energy transition, the long duration storage. So cool to see the start of that.
Well, as China progresses down its renewable energy future, the EU and the United States are going in hand-to-hand combat because the IRA bill, and the European Commission wants to try to balance that a little bit because all the energy, literally speaking, is happening in the United States. So the EU is trying to set some requirements out and say, hey, we want EU industry to stay in the EU. And they're aiming to produce like 40% of the clean tech products within the country by 2030. They're trying to shorten the cycle time down for permitting decisions to try to get down to 1 year. Because right now it's 3, 4, 5 years or longer in a lot of cases. And so they're trying to match the IRA bill, sort of dollar to euro. And Wind Europe, which is the Wind Energy's industry group, said the Commission's proposals don't do enough to get the EU to its energy future, basically because they don't have enough factories. If you want to create this infrastructure, you need to start building factories. Those factories haven't started. You can throw as much money as you want to in research and technology, but at some point you're going to have to start building some factories. I think it's a pretty fair approach. and they're also like allowing obviously subsidies to happen at the country level, so a particular country can subsidize its renewable energy interest, like France has done recently on offshore wind. So this has then drawn the EU and President Biden into a meeting. So EU President Ursula von der Leyen and Joe Biden met to diffuse the tensions that have come up over the last several months about the IRA bill. And a couple of outcomes on that. Basically, President Biden says, hey, yeah, America's going to back down. It's going to be cool. Don't everybody get upset with me right now. It's going to be fine. We're going to try to balance the EU and the United States manufacturing so we're not monopolizing those industries. I don't know if that's even possible, but that's what they're talking about. And they're trying to keep like Vestas in the EU and not move it to America. I mean, that's literally what they're talking about. The one area which I think is still under dispute is the $3 tax credit per kilogram of clean hydrogen. That hasn't gone away. And I don't know if the EU can even try to match that. But at the end of the day, if the EU is putting a bunch of money into renewables, and the IRA bill, which is putting about $700 billion into renewables, now you got, instead of one money pump, you've got two on either side of the ocean. That's going to make the companies very wise, Joel. Like GE, Vestas, and Siemens Gamesa are going to realize, I got money on both sides of the ocean. I'm going to tap into both of those simultaneously, right? That's the right answer if I'm a business, and they're in trouble right now.
Yeah, I mean, it's going to be all driven. The rest of it's driven by demand, right? So right now, there's only so many factories. They can only produce so many, say, wind turbines or so many heat pumps, so many of these things, right? So that's why the EU is saying, hey, wait a second, we need to have some fair playing ground here, because otherwise everything that gets produced is just going to go away and we're not going to get any of it. So, I see that what they're trying to do here, but unless they address the complete supply chain, this money doesn't really help or doesn't even the playing field, because everybody's going to be playing for just the limited amount of finished resources that are being created.
And then in a joint statement, the EU and the United States put out, it says, quote, we are working against zero-sum competition so that our incentives maximize clean energy deployment and jobs and do not lead to windfalls for private interests. Now, I don't know of any government agency that's building wind turbines at the moment, so pretty much anybody that's involved in renewable energy is a private interest. And now you just created two pools of money for private interests to go after. What happens here? In the EU, I guess they do have windfall profit taxes and they go after, but in the United States, you do not. So there is no way Congress is going to pass windfall profit taxes. So it still makes sense if I'm GE, Vestas, and Siemens Gamesa to put the plant in the United States, because you're not going to claw back those profits. In the States, they won't. Yeah,
you're turning it into the old statement of like the rich get richer, and the rich being the people that want clean energy. Because what it will create is now our friends in South America, say Argentina, Chile, Brazil, Mexico, everybody else that's trying to have an energy transition, even the Canadian companies, everybody else that's trying to get on board with a clean energy transition to help the entire world is going to be SOL, because all of the money is going to be going states and into the EU, because there's just not enough resources to build everything.
Yeah, Canada's already complaining about it, and rightly so. They're trying to figure out how to match the IRA bill also. So then you have a third entity trying to match this pot of money. So now there's even more incentives to try to grab hold of that cash. And there's going to be profits. There has to be. And the weird thing about all this is that who's making money right now? Windfall profits is not even in the discussion point of Vestas, Siemens Gamesa, or GE.
That's a problem they wish they were having.
They wish they had that problem, right, Rosemary? Right.
Yeah, it's something I get asked about a lot. I've been doing a few interviews and stuff recently about the wind industry and by finance people. You know, there's heaps of finance, renewable energy communication out there. And they always ask me, you know, I was so surprised that we're in this huge renewables boom. People can't, get the wind turbines they need to put them in the ground fast enough. But when I looked into it, there aren't any profitable wind turbine companies. So why is that? How does that make sense? And it's a shame that I'm getting asked this because, by finance experts, because I'm like, please, can you tell me why this is happening?
Yeah, it should be you guys telling us. Yeah.
It's definitely a strange situation. I don't know. I haven't looked closely enough into the IRA and other related IRA, whatever we're calling it, other related bills to see, exactly where all the money's going. I've kind of focused a lot on the $3 a kilo, or even I saw $3.50 a kilo somewhere, subsidy for hydrogen. And my big problem is not like, I'm not like a pure capitalist, make the, competition, let the weak die off or anything like that. Like I'm happy to see subsidies for technologies that we need, and that need, a little bit of a help, especially in that first phase of their development where they're trying to, get enough units out there that they can start to, get them cheap and sustainable. But the problem with the hydrogen subsidy is just too big, and it's going to distort things. And like I've whinged about hydrogen a lot on this podcast and other places over the last couple of years, but it's not the most efficient technology. It should be the technology that you use when none of the more efficient ones can do it. But when you throw this much money at it, then you're going to start using it for everything. It's like if I don't know, car mechanic showed up with just a Swiss Army knife and wanted to use that to fix your car. It's like, yeah, you could do it, but it's not the right tool for the job. And you lose out when you try and use the wrong tool too much. And if, depending on the application, using hydrogen is going to be like 2 to 6 times as much renewable energy that's needed than if you just directly electrified those same applications. So it actually risks slowing the energy transition globally by throwing too much incentive to start producing hydrogen, without any thought of what it's for.
No, that's been part of the problem with the wind industry, right? Is like, even so, take the United States, we talk about the IRA bill now, but PTC credits have been in play for 30 plus years. I think it was like 1994 or something, 93, that the first PTC credits came into play. So when you have an industry that's been around for 30 years, that's been propped up its entire life by subsidies, there's a false floor there, and a false ceiling. Like nobody really knows where you should be able to figure out where the economics fall. But when you're playing apples over here and oranges over here with different kind of subsidies everywhere, you get so far down the line that it's been propped up and held up by government policy. And then when it's expected to try to stand on its own, it kind of, because a year and a half ago, nobody knew that the PTC was going to be extended. Nobody knew this IRA bill was coming. They knew it was being worked on, but it was a very real possibility that it wasn't going to get passed. So there was a lot of wind energy producers in the US were staring at the end of PTC for the first time in 30 years. And, things changed in their mindsets and how they were starting to operate O&M. And then boom, it happened again. So now we've got this new windfall of PTC credits we can take advantage of. Let's repower. Let's do this. Let's do that. So we talk about things with Phil on the show quite a bit about repowering at 10 years. They're taking down equipment that works just fine, but it's been driven by government subsidies and government policy that we have basically altered what a free market would look like versus what it is being operated as now. And that's the issue, because if we have to come crashing down to reality, the economic models need to change. And that's why we're in the state we're in. And that's a very vague, I guess, explanation of my thoughts on the economics of it.
Hey, Uptime listeners. We know how difficult it is to keep track of the wind industry. That's why we read PES Wind magazine. PES Wind doesn't summarize the news. It digs into the tough issues. And PES Wind is written by the experts, so you can get the in-depth info you need. Check out the wind industry's leading trade publication, PES Wind, at peswind.com. All right, Rosemary, your old stomping grounds, GE, has announced that it's planning large-scale demonstrations in 2024 following successful testing of its first direct air capture prototype. It's been a combination of GE Research and GE Vernova that have been working with the Department of Energy and the ARPA-E project to develop better CO2 removal methods David Moore, GE's carbon capture breakout technology leader, said, quote, "If we do this right, we could have a commercially deployable direct air capture solution around the end of the decade, which is 2030. With the new GE direct air capture system, the thermal management design has been optimized so that the CO2 absorbent material removes the maximum amount from the air. And GE is investing into this technology, trying to create some more breakthroughs in the technology. Rosemary, I know you said this is like the last 0.5% or 1% of the carbon future or carbonless future. Does this new technology increase that percentage? Like, is it the last 3% we can go after with the direct air capture, or is it still like 0.5%?
I don't know if I don't know if I would get stuck too much on how much of a percent it is. But I think the thing that you should never talk about direct air capture without also talking about the energy requirements that it has, because you need a lot of energy to power direct air capture. And if you were to power it with, with, I don't know, a coal power plant or a gas power plant, then you will end up emitting more than you're, soaking up for, or maybe not more, but you're not really coming out ahead in that way. So it can only happen in parallel with like really fast and aggressive emissions reductions. It makes zero sense to think of it as something you do instead of emissions reductions. And certainly it's not, a world that's still making electricity with coal power plants is not one that, can just be mopped up with direct air capture. It's definitely not on that scale. So yeah, it is the last little piece of the puzzle. And I think direct air capture really divides people because it sounds like giving up, right? That and it sounds like it's a bit of a moral hazard. It sounds like we don't need to do any of the hard work of the energy transition if we can just get direct air capture to work. And I can kind of see that point. But on the other hand, we are going to, no matter how aggressively we reduce emissions, we are going to end up in a world that has more CO2 in the atmosphere than it has done historically. And the only way that we're going to get closer to historic levels is by bringing it down, either with something like direct air capture, or maybe it's going to be, with bioenergy, carbon capture, something like that is probably going to be needed. So I kind of like that people are working on it, and I hate that they're talking about it. Just, quietly go make this technology work. I understand that it's a difficult thing. You need to make it more energy efficient. You need to scale it. You definitely need a lot of attention on that now if we want to be using it in 20 years at any scale, at any, meaningful scale. But yeah, just don't talk about it to with your, everyday regular people, just like I'm doing right now. Don't give anyone the impression that, there's an easy solution coming. That's the problem is, like everybody wants attention on their project. They want to make it sound like it's going to change the world. And so you end up with these hyperbolic headlines that really exaggerate things, make it sound like a free lunch when it's not a free lunch. It's, a really, really expensive cleaner to come in after, you've done everything that you possibly can. So, yeah, cool, but let's just shh.
So this article and this news from GE sort of ties into something that's happening in Japan. And I saw a news article today talking about a coal-fired plant in Japan where they're using oxygen to feed that coal plant, which then makes it burn a little more efficiently. Then they're using carbon capture to get a significant amount of the carbon out of the emissions there. And then they're getting, as a byproduct, hydrogen out of this plant. As a sort of a stepping stone. And I wonder if this is where this carbon capture technology is kind of going is, hey, in some parts of the world, you're just not going to get away from coal plants straight away. But at least we could start pulling some of the emissions down a little bit.
No, you'd never use this near a point source of emissions. This is for like super low concentration that's in the atmosphere that you can do anywhere. If you've got a concentrated source, like on a coal power plant or cement manufacturing facility or, something else like that, or steam methane reformer, grey hydrogen facility, then you've got really concentrated CO2 at maybe like 15% thereabouts, and then you can use other way cheaper methods to capture it. So it's way better in that case to use like a normal carbon capture method. However, it still adds a chunk, like even that better, much more energy efficient traditional carbon capture. I probably shouldn't call it traditional because there's definitely not a tradition of these things working. But even in that, mainstream technology, it still adds 30% approximately power consumption. So if you put it on a coal power plant, then 30% of your power output you're going to be using to power the carbon capture. So you can see it's the same sort of problem where you're just adding to the energy requirements, and that's much less energy than what you need for direct air capture, where you need to move vast volumes of air through because you've got these fractions of a percent that you're trying to concentrate and remove. So I couldn't say it too many times that this doesn't coexist with coal power plants or any. Coal is just the easiest slam dunk of a thing to just remove it. There's plenty of better, cheaper, just better in every way technologies to replace it. So it's so much cheaper and simpler to get rid of those. I think that's one of the big problems with carbon capture as a technology, is that early on it was sold as a way to continue with, traditional thermal generation from coal and gas. But it makes it it's a logical inconsistency to do that. It just makes no sense. You're just ending up with a more expensive product out the end compared to something that's green to start with and doesn't have any emissions.
I think something to concentrate on here from this article is that David Moore from GE, as you were saying, Alan, he says, if we do this right, we could have a commercially deployable DAC solution around the end of this decade. That does not mean commercially viable or commercially solvent. It just means deployable.
Yeah, that's a lot of work to do still.
Yeah, I mean, if you think about it, how could you have a commercially viable system when there's no value for CO2? There's very few places in the world where you're charged to put it into the air. And this isn't even what that is. This is pulling it out of the air. And then to spend money burying it, we haven't yet got a mechanism to attribute value to that so that it could be commercially viable. You couldn't even start to make a business case for it now, except for involuntary carbon reduction markets.
I watched a GE video today on LinkedIn of all things, and they were talking about what they're going to do with this carbon. And one of the answers was aviation fuel. So they'll take the CO2 and then make it into aviation fuel, which seems like the most expensive way to make aviation fuel is to do that, is to use carbon taken from the air.
It sounds like you don't need to worry about aviation. It sounds like you're pulling carbon out of the air. So already in just that immediate 1 second interpretation, the average person's going to have, they're double counting what's happening to that carbon because, you pull it out of the air. So you feel warm and fuzzy about that. Then you put it into an airplane, so you won't feel warm and fuzzy about that. But where's it going out of the airplane? Back into the air. So, you end up back where you started in terms of CO2, but with a lot of energy used that wouldn't have been used otherwise. So, that's the problem, is that, you talk about it, it makes you feel like, oh, these things are under control, but they're not under control. And that's not going to be you can't have that as your solution to aviation without then pulling out a bunch more CO2 from the air and storing it, never putting it back out there. So you should, if you want to feel both of those warm, fuzzy feelings, you're going to need to be pulling out twice as much from the air as what you're using in the airplane. Otherwise, you just end up back at zero.
Yeah, I don't think it's realizable. I just think it's interesting on the PR approach more than anything.
But I do think it's important. I mean, the timeline doesn't surprise me that's, when it will be ready to, physically ready to go out there and do its thing from an engineering point of view. And like I said, I don't think you can even guess what the commercial impact will be like at that point, because how will we value carbon removal in 10 years' time? I've got no idea. But I do know that if we want to be pulling significant volumes out of the air in 2040 and 2050, then we need to be doing those small things that sound meaningless now in order to get there. So I think it is really good that people are working on this. I don't want to be too dismissive, but at the same time, I do, because I don't want anyone to think that this is going to make a big difference and stop doing all the other things.
So at Blades USA last week in Austin, Texas, there was an announcement made from Onyx Insight and Nearthlab. And Nearthlab is based in South Korea. They're a drone company. And Onyx Insight and Nearthlab are going to be working together in the United States. And Onyx is going to have access or licensing Nearthlab's zoomable, it's called zoomable software to look at the health of wind turbines. So it's pretty much the Nearthlab has a bunch of drones. They have a kind of a cloud interface where they put all that data, and it helps an engineering company like Onyx go through and predict when maintenance needs to occur. And that's a unique partnership, because Onyx hasn't really done a lot with anything drone related, and Nearthlab hasn't done anything in terms of helping to fix blades necessarily. So right now it looks like what Onyx is working to do is they're mostly in the vibration business. They're looking at vibration of gearboxes and turbines and helping do predictive maintenance on the turbines. So now they can add blades to that mixture because of the drone technology. And that expands their capabilities. So it says, Onyx Insight is now able to monitor about 85% of major component failures with this partnership. So this is kind of a unique thing that's happening. I think more of this is going to happen. Joel, you've seen this a little bit. SkySpecs has done something kind of similar, where they're trying to bring it in-house. There's been a couple other players that have been trying to do similar things with you guys at Wind Power Lab, right?
Yeah, I mean, at Wind Power Lab, we do some of the same kind of concept of this as far as using, because we're not a drone company, of course, but we're a blade expertise company. So it's kind of the same thing. Onyx Insight, great at monitoring a lot of different components within the turbine, but they also do have some blade experts on staff. And so they do a little bit of blade stuff, but they're not a drone company, right? They're not out flying and inspecting things. So they rely on third-party people to do that. And at Wind Power Lab as well, once you hook into a third party that you really like to use and you trust them and the data deliveries are good, they're professional in the field, all those good things, then you sync up with them, and then it makes the workflows easier. It's easier for both of the companies. It's a value add for both of the companies, but it's also the heart of it, it's a value add for the client. And that's where it's at. So Onyx Insight has a whole suite of clients that they help out regularly with. They have their own CMS systems for vibration and drivetrain monitoring things. And then they have, our friend Megan Rotundo over there that has been helping people with blades. Now she has a whole other tool as a value add to bring it in. So, and I know Nearthlab's created a software much like Sulzer Schmidt kind of has, where they can go and now have inspections field deployable, which Thread does the same thing, and I think a lot of people will start to move that way, is it cuts down on the need to deploy drone technicians and pay travel and pay mobilization and pay all this stuff. You just buy the drone as a wind farm or as a company, and when the wind is what's the word you use, Rosemary? What's the German word for the wind is dead?
Dunkelflaute.
Dunkelflaute. Dunkelflaute. There it is. So how about when the wind isn't blowing, for our English listeners? When the wind isn't blowing, and you can go out and do inspections, right, at any time. So you're not paying downtime, and you might get 2 or 3 done this day, and you might get 2 or 3 done this day, but you can be regularly out there. Instead of paying someone every year, you could be out there every quarter. You could be out there whenever a storm comes through and there could be some lightning, So if they can get the interfaces worked out between the two of them, Onyx Insight and Nearthlab, it could be a very good pairing for a lot of Onyx's companies. And then South Korean company, Nearthlab, being able to export their technology around the world will be great for them. I know as they grew, they received a lot of awards in South Korea. They also received a lot of government funding to grow and grow and grow, and they've got a lot of really smart software people over there building some solutions. So I'm not sure. Do you think they will white label what Nearthlab has in the background for the zoomable software for assessing the health of the turbines, or will they use some Onyx Insight input with that? What do you think?
That's a good question. I did run into Megan at the conference. I didn't ask her about that. That's a really good question. We should try to get her back on so she can describe what the relationship is and how they're going to use this data.
I think you'll start to see a lot of people or a lot of companies move this way. I mean, you already have, like you see this going. We've seen SkySpecs partner with, our friends at Power Curve, a lot of really smart guys over there. And so you have subject matter experts joining up with some of the drone companies and inspection companies to give a better value add to their customers. And I think that's what will start to differentiate in the market, who's going to continue to grow.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
And Joel, you and I talked a couple of weeks ago about drone inspections happening on concrete towers, and we guessed that it was Nordex turbines that were having some troubles, maybe end of warranty campaigns that were happening at the time. Well, we were probably right. So Nordex is knocking down 4 wind turbines in Germany due to concrete towers that have defects, and all 4 turbines on the wind farm are going to be completely dismantled, and they're going to put up brand new turbines in their place. And they're 4.5 megawatt machines. So this is not cheap. A 4.5 megawatt machine is about $4.5 million, plus all the new infrastructure from the pad and everything else. It's going to be an expensive concrete tower replacement job.
But they're just doing the towers, right? So they're going to take the blades, rotors, spinners, nacelles off, set them to the side, and then blow the towers up, and then put new towers and put the same nacelle back on.
I think they're going to knock them down.
The whole thing?
Yeah, it sounds like they got a structural concern and they don't want to be putting a crane near that, trying to disassemble it. That's what it reads like. Now, I could be completely wrong, but I was just trying to read between the lines of what the effort was. But this says they're going to be completely dismantled, and they're going to put the turbines up in the same place. But
and they're lucky for the labor laws in the EU, because if that was someone in the US, they'd be looking for a new job.
I think there is a big growing concern about concrete pads and concrete towers, and do we have enough history on them to know what the lifespan is, and are we designing them correctly? When we were at the ACP OMS show in Orlando, there was a discussion in one of the sessions about, have we put enough basically steel in the concrete, and is it set up correctly and tied together correctly so that it doesn't pull apart? I think the answer was no, based on what we know.
That one in Illinois just went over, right?
Right. And there was some comment online about that saying, well, there should have been some more horizontal steel in that rebar in that mix, and there wasn't, but that was the way we did it at the time. If we had to do it again, we would do it differently. So obviously, it's Monday morning quarterbacking there. But if you have several thousand turbines, and Nordex does, on concrete towers, I think you should start to worry a little bit about it.
There is a company in Germany, and I can't remember the name of it, but at Wind Europe, I believe, maybe 2 years ago, they were across from Wind Power Lab. We had a booth there, and they were in the Innovation Hub, and it was I can't remember the name of them. I can picture their logo. It was orange and black, but they were doing pre-stressed concrete wind turbine foundations, but they're doing them in pieces like Legos. So instead of pouring in place, they brought the pieces in on trucks, and then you just kind of set them like Legos. And then, so you'd think they were a Danish company, but they're actually German. And then that was the foundation. And they won some awards with this. But I don't know how it's taken off commercially. We should circle back around. I want to say it was Anchor was the name of them. Yeah, it's I don't know where they've gotten commercially with it. I know when I looked at there's a couple of friends here in the U.S. and they're like, hey, when you go to Wind Europe, check these guys out. And I looked into it with them, and they did a great job on the show floor with having some engineers and stuff there. So I'd be curious to see what kind of traction they've got in the marketplace.
Rosemary, some of your former colleagues have started a company called Gulf Wind Technology, and they have partnered with Shell New Energies in the U.S. to develop hurricane-proof wind turbines for the Gulf of Mexico. And Shell has committed $10 million towards this effort, which is going to be based in Louisiana. The accelerator program looks to develop, test, and deploy a Gulf of Mexico specific demonstrator turbine as early as 2024. Now, I crossed paths with one of the people at Gulf Wind Technologies at Blades USA. It's like, and I was asking him, 2024 is pretty soon to put a demonstrator together that's going to handle hurricane winds. And it sounds like they're going to try to take it in stages, a very logical approach. Not try to build a 50-meter blade that's hurricane-proof, but maybe build something shorter, try to do proof of concepts, and then develop this into a full-scale wind turbine system. With the leases going on the Gulf of Mexico over the next 6 months, a year or so, Joel, I don't remember, it's pretty soon. They don't have wind turbines to put out there yet, right? So they're still trying to figure out, like, if I put a wind turbine out there and the winds are lower, right? So the wind speeds are like 7 meters a second, or some kind of number like that. It's relatively low compared to some other places, like in Kansas or Oklahoma. You have low winds speeds, and then you have these high, massive speed swirling winds that a wind turbine blade has to withstand. Rosemary, what's this blade going to look like? Is it going to be made out of aluminum? Aluminum.
You've been in Europe too long. Aluminum.
Yeah, no kidding. Aluminium.
Are you trying to say aluminium correctly? Is that your problem? You're trying, yeah, aluminium, that's better. Yeah, I assume it's going to look really, from the outside, it's going to look more or less exactly the same as any other wind turbine, but it's going to have thicker skins on the blades. Maybe they'll shorten the blades. I'm not sure. I don't think that their biggest challenge is designing a wind turbine that can withstand these loads. I think they're going to have two problems. The first one that any manufacturer would have if they chose to make a wind turbine for that application, which is that, when you've got low average wind speeds but very high extreme loads, you have to design for the extreme load, so you put a lot more material in there to make it strong enough to withstand it. Costs a lot more, but you can only recoup, you don't generate power during those extreme times. You have to generate your power during the low average wind speeds, and so you've got an expensive turbine that doesn't make a lot of electricity. So the main problem is the economic one. You're not going to need any new, unheard of technology to make these turbines strong enough. Anyone could do it just by, like I said, making the fiberglass a bit thicker than it would otherwise be. And like I said, also maybe make the blades a bit shorter so that there wasn't as much force on it. But of course, then you get less energy generated if you've got shorter blades. But the biggest problem would be starting a wind turbine manufacturing facility from scratch. So I assume that they're not doing that. If they're going to put out their first turbine in 2024, it's not going to be them making the tower, the generator, the blades, all that. Maybe they're putting stronger blades onto an existing turbine that's rated for those loads. Maybe that's how they're doing it, and their point of difference is only that they're willing to make this product when others don't see the the business case for it. They don't see that they would sell enough to warrant the effort. So and you guys would have a better idea than me about how much opportunity there is. Like, is there a big enough market there that it's worth specializing on that?
Right now, there's two, yeah. They're getting smaller by a minute.
Yeah, they are. They're shrinking them, but that's one place that you can go with them right away, right off the coast of Louisiana. Boom. But there's also other places in the world that could use these, right? In the APAC region, some of those Typhoon, like Mingyang has the Typhoon class turbine now. There's other places they could use them as well. That would just be a Kickstarter here. So a question I have for the team here is, we're talking about blades, but is there other things that you need to do? Like, would you like to have a more responsive, faster yaw motors to be able to spin the tower faster if the winds are changing instead of just letting it free float? Or is there anything else that you would change? Do you need bigger main bearings because of the forces that you might endure?
Everything will need to be changed for the bigger, more heavier, stronger blades. I mean, even aside from anything else, if you if you make a wind turbine blade heavier, then you've got to add mass all through the rest of the tower. It's one of the reasons why you see carbon fiber being added to blades to make them lighter. The wind turbine blade itself is more expensive actually to do that in many, maybe all cases. But where you save money is by being able to take weight out of everything else that's attached to the wind turbine blade, which is, everything, because the blade is the first thing in the train. So I don't know what they're doing, but my assumption will be that they'll take a turbine, everything minus the blades, they'll take that from a bigger, higher rated, turbine, and then put smaller, shorter blades on it. So you'll end up, some parts of the turbine will be overbuilt in order to make sure that none of it is underbuilt. They'll make the changes necessary to the blades, and then, maybe this is their proof of concept. And as time goes on, they will gradually, take out some of the material from other things that are overbuilt. But that would be my guess of how you do it, because to start optimizing everything as a whole is going to just, they'll never get enough money to make their first turbine like that. They would have to do it in an agile way. And I know the company that I'm assuming that these guys came from, I know they came from GE, and before that they were probably part of another company that was bought that was in that location in Louisiana, and they were really agile company, really doing, like cutting edge stuff with wind turbine blades. And they're really used to thinking, what's the quickest way that we can test the, crucial assumption of this? How can we get to a minimum viable product as soon as possible? And so that's why I'm pretty sure that they'll be taking that kind of agile approach to this new company.
And Shell, partnering with Shell, or Shell being a part of this, is fantastic, because Shell has a ton of knowledge of the offshore working conditions in the Gulf. They've been out there for 40 years.
Yeah, I think this initiative is going to carry over. You've seen a couple other companies, I won't name them now, that are doing very similar things. They're kicked off these initiative programs where they're willing to put some money behind a startup company to help them in certain ways. This is the first one I've seen that's been direct to wind turbine tech. Like, there's a company that's in this, that does this for a living, and we're going to speed them up to make a product that we need in the Gulf, and probably down in North Carolina, South Carolina region also, because hurricanes come up the East Coast too. It would make sense if you have that technology in the Gulf of Mexico. Why would you not put it in North Carolina? Same conditions. Our wind farm of the week is the Strauss Wind Energy Project in Lompoc, California. And there's going to be 27 GE 3.8 megawatt turbines spinning out there relatively shortly, with just enough to power about 44,000 residential homes. This project has been going on a little over 20 years. It began in 2001, and then it changed hands in the middle here. There's been some issues with the soil in that site. And if you're familiar with Lompoc, California, that's where Vandenberg Air Force Base is. So they do rocket launches, polar rocket launches. When I worked for GE, when they had an aerospace division, we were doing launches out of there. Really cool site. So they have had some soil issues and some setbacks, mostly due with the Santa Barbara County Planning Commission. It looks like as of right now, there's about 25 turbines done and ready to go, but the county has laid on about 103 conditions, including environmental mitigation, that have to be checked off before they can go live. 103 conditions seems like a lot, Joel, but they're almost done, which is congratulations to them.
That's crazy.
Yeah, but it is good. So, it's for a wind farm that's been through 20 years of struggle, it's nice to see that being completed. So our wind farm of the week is Strauss Wind Energy in Lompoc, California. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform. And be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy Podcast.